with the previous things we had, probably with the name node. So is something that runs in memory, okay, and we will use that at a high configuration hardware, and data will not be stored in the name node, okay, and there will be only one name node, okay, and name node is also we'll be configuring it into the configuration file along with the other nodes, and name node is the main responsibility to maintain the replication factor, okay. So I can give you some scenarios like if what happens if the data node is failure, okay. So all the data node will be it will be sending the hard bit to the name node, and it's like every 10 seconds the data nodes will be sending the hard bit, okay. If one data node is getting failure and it doesn't send the hard bit to the name node, then the name node will decide to replicate the last files with using its metadata information, okay. Node was earlier replicated with the file, okay. So something happens to any of the data node, the name node has the full rights to full rights to copy the file to the another data node, okay. So it will be let's get into the data node. So it will be sending heartbeat every 10 seconds, and it will also sends the block report, okay. So basically, like, block report is like it will have all the information on the health of each block, okay. It will also know that what node to be decommissioned or dead blocks or any blocks which is which needs to be sent error, okay. So data is always stored in data node, and data node will be like any other nodes, okay. So we will be configuring it in the cluster itself, okay. And the next thing we saw is like rack awareness. So rack awareness is a kind of formula. So in Hadoop rack awareness, like so we'll see like how it will be so in case like a file retrieved from a cluster, okay. So like how a file will be retrieved from a cluster, okay. So rack awareness plays a major role in the place. So a name node has the metadata information like along with the rack awareness, okay. So first name node will look for the shortest distance in the rack, okay. So like which data center is the nearest one and which rack is the closest one, and inside that which data node is the one, okay. So it always look for the shortest distance from the rack, okay. That's the formula. And moving on, what else we saw? I mean, last week, like we also saw like see in the single point of failure, there is something called speculation execution, okay. If name node fails, it is called as single point of failure, okay. System will be down with MapReduce 1, that is and in Hadoop 2 it is having a high availability, okay. So in maintenance activities, like if there is a power failure or shutdown in the cluster for a moment, that happens to the data in RAM, okay. So my question is like, what happens to the data in the RAM? So see, name node is always it writes an image periodically, okay, and it is called as FS image, okay. So FS image will be available only in the name node, and FS image also is created by it is basically created by a secondary name node, okay. And what else we saw? I mean, like and in production, basically we will be using a lot of shell script in productions, okay. Okay, so let's begin with some of the components of Hadoop ecosystem. Okay, so Hadoop will begin with HDFS. Like this is a distributed file system that provides a high throughput access to the application data. Okay, so this data in a Hadoop cluster is broken down into smaller pieces and is called as blocks. Okay, so and it is also distributed throughout the clusters. In this method, the map and reduce functions can be executed, or and in a smaller subsets of your larger data sets. Like, and this provides scalability which is needed in the big data processing. Okay, so you know how much HDFS as we are covering in the last sessions, right? So let's move on to the next component. See, basically today's agenda, like we'll be discussing with the terminology related to big data ecosystems and big data and Hadoop ecosystems. Okay, so this will give you a complete understanding of big data and its terms. Okay, and over the time, see, Hadoop has become the nucleus of big data ecosystems. Okay, so where many new technologies have emerged, but have not. I mean, like it's not getting integrated. Okay, but Hadoop is very much integrated with big data challenges. Okay, so it is important that we first understand and appreciate the nucleus of modern big data architecture. Okay, so the Apache Hadoop software library is basically a framework that allows for the distributed processing of large data sets across clusters of computers. Okay, and using very simple programming models. Okay, so it is basically designed to scale up from single servers to thousands of machines, and each offering local computations and storage. Okay, let's jump into each one by one. Okay, so MapReduce. So MapReduce is basically a programming model specifically implemented for processing large data sets on Hadoop cluster. Okay, so this is the core component of Hadoop framework, and it is the only execution engine which was available in Hadoop version 1. Okay, so the MapReduce framework consists of basically in two parts. The first one would be like map, and second one is reduce. Okay, so the first one is called as map, which allows different points in the distributed cluster to distribute their work. Okay, so a function. The second function is called as reduce, and this is basically designed to reduce the final form of the clusters and resulting into. Okay, so the main advantage of the MapReduce framework was for its fault tolerance, and where periodic reports from each node is in the clusters are expected as soon as the work is completed. That's great, right? So the MapReduce framework is inspired by the map and reduce functions, which is used in the functional programming, and the computational processing occurs on the data stored in file systems or within a database. Okay, so which takes basically like which takes at a set of input keys values and produce a set of output key values. That makes sense, right? So each day, like numerous MapReduce programs will be MapReduce jobs are executed on Google's clusters, and programs are automatically parallelized and executed on a large clusters of commodity machines. Okay, so MapReduce is used in distributed grep and distributed sort, and what else, like web link graphs, web access log stats, and documenting clusterings, machine learnings, and statistical machine translations like that. Okay. Next tool is like Pig. So Pig is a data flow language that allows users to write complex MapReduce operations in a simple scripting language. Okay, then the pig transforms those scripts into MapReduce job. Okay, so MapReduce is basically it's written in Java. You can do it in Python as well. If you're not familiar with any programming language, don't worry about it, because you are going to learn a new scripting language, and that is called as pig. Okay, so a pig basically it allows basically it is like it flows the language that allows the user to write any kind of complex MapReduce operations. Okay, and this scripting is very simple. It will be in very, like, if you're writing in 400 lines, you will be writing pig scripts in hardly in 10 to 15 lines. That's amazing, right? So then basically pig is transform those scripts into a MapReduce job. Okay, so know about it. We have more to cover about MapReduce and pig and other tools in a separate session. So we are just walking through Hadoop introductions, basically like I touch up with Hadoop ecosystem. Okay, so next is like Hive. So Apache Hive is a data warehouse software which facilitates querying and managing large data sets residing in the distributed storage. Okay, so Hive basically it provides a mechanism for querying the data by using a SQL-like language called HiveQL. Okay, so basically it was called as HiveQL. Okay, and at the same time, this language also allows traditional MapReduce programmers to plug in their custom mappers and reducers, and when it is convenient or inefficient to express the logic in HiveQL. Okay, so this is also one kind of scripting language, and you can use this as a replacement of MapReduce. Okay, I mean, like, if you don't know to write in Java or any programming language, you can go with Hive and pig as well. Okay, so this is inside the syllabus. We'll be covering a lot of Hive queries in the future classes. Okay, so it's going to be complete practical. And the next tool is like Scoop. So see, enterprises that uses Hadoop often find it necessary to transfer some of their data from traditional relational database management systems. Okay, and basically to the Hadoop ecosystem. Okay, so I mean, like, if you want to transfer some RDBMS data to Hadoop ecosystem, you will be using Scoop a lot. Okay, so Scoop is an integral part of Hadoop and can perform this transfer in a automated fashion. Okay, and moreover, this the data imported into the Hadoop can be transformed with MapReduce before exporting them to the RDBMS. Okay, so Scoop can also generate Java classes for programmatically interacting with imported data. Got it? So Scoop uses a connector which is based connector based architecture that allows it to use plugins to connect with external database. Okay. So next is Flume. So see, basically, like, the difference. See, Flume is also like kind of will be using a lot like Scoop, but there will be some difference. Okay, so Flume is a service for streaming logs into Hadoop, like Twitter logs or any real-time logs. Okay, so Apache Flume is distributed, reliable, and it is available service for efficient collecting, aggregating, and moving large amount of streaming data into the Hadoop distributed file systems. Okay, so the main difference would be like with Scoop you can do like both parallel movement. Okay, like you can bring back to RDBMS from Hadoop system. You can you cannot do that with Flume. Okay, so I'll tell you that more in detail because we'll have a separate session for Flume and Scoop as well. And the next is like Storm. So Storm is distributed real-time computation system for processing large volume of high-velocity data. Okay, so Storm is extremely fast, and it can process over 1 million records per second per node on a cluster of modest size. Okay, so enterprises basically it harness this speed and combine it with other data access applications in a Hadoop to prevent undesirable events or to optimize positive outcomes. Okay, moving on. So next is Apache Kafka. So
I
Apache
think your screen is not visible.
Oh, is it? Okay.
Okay.
Give me a moment, guys. I had some attacks in my system and it's malfunctioning. So you are going off, right? So is it visible now? I think it should be visible now. Right. Okay. So moving on, like Apache Kafka, it supports a wide range of use cases such as as a generous purpose messaging system for scenarios where high throughput or reliable delivery and horizontal scalability are important. Okay, so we'll look into Apache Kafka and use cases in the session coming sessions. And Apache Storm and Apache HBase basically they both work very well with the combination of Kafka. Okay, so our Kafka is something it was linked in. Okay. Next is moving on Oozie. So Oozie is a workflow scheduler system, and basically this scheduler system is to manage Apache Hadoop jobs. Okay, so the Oozie workflow jobs are directed acyclical graphs like DAGs of actions, and whereas like the Oozie coordinator jobs are recurrent. Okay, and it's basically like OZ workflow jobs are triggered by time, frequency, and data availability. Okay, so OZ is integrated with the rest of the Hadoop stacks, and it supports several types of Hadoop jobs jobs out of the box, such as MapReduce, streaming MapReduce, Pig, Hive, Scoop, and DistCP, and as well as like the system-specific jobs such as Java programs, shell scripts. So Uzi is a scalable and reliable and extensible system. Okay, and Apache Spark. Okay, so this is the latest technology you need to update after Hadoop. So Apache Spark is a fast and in-memory data processing engine, basically for the distributed computing clusters like Hadoop, and it runs on the top of existing Hadoop cluster, and it accesses the Hadoop data store like HDFS. Okay, so Spark can be integrated with the Hadoop 2 and Hadoop 2 Yarn architecture, but you cannot use with Hadoop 1. Okay, so this is entry point of question, like, can you use Hadoop? Can you use Spark in Hadoop 1? So obviously you cannot use it, because after Hadoop second version only you can, you can use Spark. Okay. So moving on, Solr. So Apache Solr is a fast open source Java search server. Basically, like Solr enables you to easily create search engines and that search websites, database, and files for big data. Okay, so so far this is the fastest search engine open source Java search servers. Okay, so so far we had different technologies, but Solr is the fastest one for any kind of search engines. Okay, and Apache Yarn. So it's a recap. So Apache Hadoop Yarn it stands for yet another resource negotiator, and it is a cluster management technology. Okay, so Yarn is one of the key features in the second generation of Hadoop version. Okay, and second generation and Hadoop 2 version of the Apache Software Foundation, which is open source and distributed processing framework. Okay, so originally Apache by Apache as a redesigned resource manager, and Yarn is also characterized as a large-scale and distributed operating system for big data applications. Okay, so moving on, I think yes, Test. So Test is an execution engine engine for Hadoop that allows jobs to meet the demands for fast response times and extreme throughput at the petabyte scale. Okay, and Test also represents computations as data flow graphs and can be used with Hadoop 2 Yarn. Okay, and this is also point of entry questions, like this was not available in Hadoop 1. Okay, similar like Spark. Next is Apache Drill. So Apache Drill is also an open source project, and it has a low latency query engine for Hadoop that usually delivers secure and interactive SQL analytics at petabyte scale. Okay, so with the availability to discover schemas on the go, Drill is a pioneer in basically in delivering self-service data explorations and capabilities on data stored in multiple formats, files, or like NoSQL database. Okay, so by adhering to ANSI SQL standards, Drill does not require a learning curve, and it integrates seamlessly with visualization tools. Okay, so next will be like it's Phoenix. So Apache Phoenix basically it takes your SQL query, compiles it into a series of HBase scans, and it coordinates the running of those scans to Phoenix scans to produce a regular JDBC result sets. Okay, so Apache Phoenix enables OLTP and operational analytics in Hadoop for low latency applications. Okay, and it does by combining the best of both worlds. Okay, and Apache Phoenix is fully integrated with other Hadoop products such as Spark, Hive, Pig, Flume, and MapReduce as well. Okay. So next, moving on, cloud computing. Of course, you know, but still, I'm like part of syllabus. So I just wanted to let you know that cloud computing is a type of computing that basically relies on sharing computing resource rather than having local servers or personal device to handle applications. Okay, so cloud computing is comparable to grid computing, a type of computing where the unused processing cycles of all computers in the network are harnessed to solve problems that are too processor and intensive for any single machines. Okay, so makes sense, right? So in cloud computing, the word could also called as the cloud, and it is used as a metaphor for the internet, basically. And this phrase is also called as computing means in a type of internet-based computing, and in which different services such as servers, storage, and applications, all are basically delivered to organizations' computer, and not only limited to computer and to the other devices like smartphones or whatever it is. It's through the internet. Okay. So next is NoSQL. So the NoSQL database is also called as not only SQL. So it is an approach to database management and database design that's really very useful for very large sets of distributed data. Okay, so this database system is non-relational, and it is distributed, and obviously it is open source, and it is vertically it is horizontally scalable. Okay, so NoSQL also seeks to solve the scalability and big data performs its issues, that is issues with the relational database where it is not designed to address. Okay, so it is better for big data projects. Okay. So moving on, Apache Cassandra, it is also an open source distributed database system. It is basically designed for storing and managing large amount of data across all the commodity servers. Okay, so Cassandra can be it can serve as a real-time operational data store for online transactional application, and a read-intensive database for large scale of business intelligence system. Okay. I'm just rushing fast because you can find the introduction. I mean, like, just look at the slides. You can find much about this in the internet as well. We are also going to cover a few parts in detail. Next is Amazon web service product called SimpleDB. Okay, so this Amazon Simple Database Service is also known as a key value data store. Basically, it is highly available and flexible on non-relational database, which allows developers to request and store data. Okay, with minimal database system, database management system, and administrative responsibility, we can use this SimpleDB. Okay, so this service also offers simplified access to any data that stores query functions that lets users to, or let you basically instantly to add data and recover or edit, like that. Okay, so SimpleDB is the best used by customers today. So basically it has a relative simple data requirement, and for example, a business might use cookies to track visitors that visit the company websites, right? Today everybody is using that. So some applications might read the cookies to get visitors identifiers, and look up the fields they are interested in. Okay, so Amazon SimpleDB basically gives the users the options to store tens of attributes for 1 million customers, but not thousands of attributes for a single customer. Okay, so moving on, it's Google's product again. I know, I mean, like you people are still you started using Google products, so know about this one. So Google BigTable. So Google's BigTable is a distributed and column-oriented data store. Basically, it is created by Google, of course, and it is it created to handle very large amount of structured data associated with the company's internet search and web service operations. Okay, so BigTable was designed to support applications which require massive scalability from its first iteration. The technology was intended to to be used with petabytes of data. Okay, so the database was designed to be deployed on a clustered systems and uses a simple data model that that Google has described. Okay, so it is a distributed and persistent multi-dimensional sorted map. Okay, so data here is assembled in order by row key, and indexing the map is arranged according to the row, column keys, and timestamps. Okay, so here compression algorithms helps to achieve high capacity. Okay, moving on, we have MongoDB. So you must be familiar with MongoDB, I guess. So MongoDB is a cross-platform document-oriented database. Okay, so it is classified as a NoSQL database, of course, and MongoDB shuns the traditional table-based RDBMS structure in a favor of JSON-like documents with dynamic schemas. Okay, so MongoDB calls the format BSON. Okay, so making the integrated of data in certain types of application is very much easier and very much faster. Makes sense, right? So MongoDB was developed by MongoDB Inclusive, and it is published as a open source, which means it's a free software under the GNU license. Okay, so as of July 2015, MongoDB is the fourth most popular type of database system, and that's the most popular document stores as well. Okay, so moving on, HBase. So I'll be covering this HBase as a separate session. It is inside the syllabus. So Apache HBase is you can call as a Hadoop database. Basically, it is also an open source. So it's also a NoSQL database that runs on the top of database and provides a real-time read-write access to the large data sets. Okay. So HBase basically scales linearly to handle huge data sets with billions of rows and millions of columns. Okay, and it is easily combines data sources that use a wide variety of different structures and schemas. Okay, so HBase is natively integrated with Hadoop and works seamlessly alongside other data access engines through Yarn. Okay, so next is Neo4j. So Neo4j is a graph database management system which was developed by Neo Technology. Okay, so Neo4j is described by its developer as an ACID compliant transactional database with their native graph storage and processing. Okay, according to database engineers and db-engines.com, Neo4j is the most popular graph database. Okay, so next will be like Couch database. So Couch database is a database that is completely embrace the web. Okay, so it produces it stores your data with JSON documents It also accesses your documents and requires your indexes with your web browsers via HTTP connections. Okay, so it indexes, combines, and transforms your documents with JavaScript. Okay, so CouchDB also works well with the modern web and mobile applications. Okay, so you can even serve web applications directly out of CouchDB. So you can also contribute your data or your applications efficiently using CouchDB's incremental replication. Makes sense, right? So CouchDB also supports master to master setups, which is with automatic config detections. Okay. So let's begin with a little hands-on, guys. Hope everybody has downloaded the Cloudera VM. So HDFS command line. So after this, you should be able to explain how to invoke HDFS shell, and we have a list of HDFS commands. So we will compare executing shell commands with using other commands as well, like HBase. So, welcome to this command line interface, guys. So, see, in this presentation, I will cover the general usage of HDFS command line interface. Okay, and commands specific to HDFS, which are often used in production. Okay, so other commands should be familiar to anyone, like with Unix experience, and that will not be covered here. But if you are very much familiar with Unix or shell scripts, obviously you can talk like anything. Okay, so the HDFS can be manipulated through a Java API or through command line interface also. Okay, so all the commands for manipulating HDFS through Hadoop's command line interface basically begins with HDFS, then SBase, and DFS or FS. Okay, so this is the file system shell, and I will show that, and this also followed by command names as an argument to HDFS space DFS. So this command starts with a dash. For example, like the ls command is used for listing the directory in a Unix command, right? So it is preceded with the dash, right? So as on Unix system, ls can take a path as an argument. But in this example, like the path is the current directory represented by a single dot. Okay, so as we saw, like we'll see in the slide, like ls command, the file system shell commands can take paths as an argument. Okay, so this paths can be expressed in the forms of uniform resource identifier or URIs. Okay. The URA format consists of a scheme and an authority and a path. Okay, so these are multiple schemes supported, and the local file systems has schemes of file, and HDFS has a scheme called HDFS. Okay, for example, let us say you if you wish to copy a file called myfile.txt from your local file system to an HDFS file system on the local host, you can do this by issuing the command like I have mentioned in the slide. So the CP commands takes a URI for the source and a URI for the destination. Okay. This scheme also is the authority to do always needed to be specified. Instead, you may rely on the default values. Okay, so the default value can be overridden by specifying them in a file name called core-site.xml in the configuration directory of your Hadoop installations. Okay, So we are not doing any installations because we are using Hadoop Cloudera. So we'll be using this Cloudera distribution, which is ready to go. Okay. So HDFS is not a fully POSIX compliant file system, but it also supports many of the commands. And basically, the HDFS commands are mostly easy recognized in Unix commands like cat and chmod, like that. Okay. So we have some specific commands. See, there are few commands that are specific to HDFS. Okay, such as copy from local. Okay, so this needs to be, I mean, like these are the things that you need to update if you know the Unix shell commands. Okay, so we'll examine few of this, like copy from local and put the two HDFS specific commands commands to do something in the same thing, like copy files from local file system to a local locations, and copying from within the file system within the Hadoop itself. Okay, so there are opposite of their copy to local command is which is also can be referred as get. Okay, so you can use get or put command as well. Okay, so this get this command copies fly out of file systems. You can specify it and into the local file systems. Okay, so we'll look into in detail in practical now. So get merge is an enhanced form of get, basically, that can merge the files and files from multiple location into a single local file. Okay, and we have setrep. So setrep basically it lets you override the default level of replications. Okay, you can set your if you're processing a file, you can basically like set how many replications manually also with command line. Okay, so you can do this for one file or -r option as well to an entire tree. Okay, so this commands basically returns immediately after requesting the new replication level. Okay, so if you want the command to block until the job is done, pass the -w option. Okay. See, there are some other distributions with Hortonworks or IBM with big insights. Basically, it provides the Ambari console as a graphical way to work with HDFS. Okay, here we will be using as Hue in Cloudera. Okay, so this service tabs provides in a simple way to view the status of Hadoop components and health checks, everything. Okay, so it creates a file view to browse and work with directories and files. Okay, so that's the end of basic knowledge on the commands. Henceforth, we will begin with lots of lab exercise. So along with the Hadoop tools. So let's move on to the VM now. Let's jump into the practical.
It's 9 o'clock.
Guys, we are able to see my screen, right? Okay, we are able to see that. Well, so see, guys, you make a note of the credential. The password would be, the username would be like Cloudera, and password also is called as Cloudera. Okay, so if in case if you are trying to navigate with the Cloudera system, you can type in. So the first thing that you'll be noticing with the browser, like this. So we'll be using Hue as Ambari, yeah, and we also having administrator here, Hadoop administrator, and basically what you need to do is click on Cloudera manager. So it takes time for me. I'm like, okay, so in your browser, you will find two different boxes. So one is Hue and one is Cloud Manager. So Cloud Manager, basically it is used for finding health checks and maintaining the clusters and other Hadoop services. Okay, so let's get into the Hadoop Manager here. So it pops up with the window, and yes, you can just simply go with I agree, or else you can go with on-screen instruction as well. So the username would be like Cloudera and Cloudera. Okay. I'll tell you one thing. In real time, you will not get this thing until unless you are a administrator or you're a manager for a project, or if you have high authenticity with your project. Okay. So here, I just walk through with the navigation. So like we have all the services here, like Flume, HBase, HDFS, Hive, Hue, Impala, indexers, MapReduce, Uzi, Solr, Scoop, Yarn, Zookeepers. So most of the Hadoop ecosystem tools are here. So here in this services tabs, we used to like see check the status of the health. Okay, so it seems like Flume is stopped for some reason. Here, I just go here in actions and I give restart. Okay. To restart the command line, yes, of course. So I just restarted, and it will be restarted in few moments. Okay. So you can give about as well. So this is very easy, guys. I mean, like if you go in production, you'll be seeing just black screens. It's basically very easy for you to understand through through GUI mode in the browser itself, right? So it says yes, so it's completed, restarted, and it is completed successfully. So now it seems like it's in good health, right? And what else? I don't want this, so I just stopped it by clicking stop. Okay, so like that you can manage your Hadoop things. So I'm stopping Solr as well. I hope everybody have navigated. No, you don't know the passwords, right? So you can navigate through this later point in time. I can simply click on the home button and check the status here itself. You can see there is some notification here, configuration. When I click on that, it says like HDFS one has one data node configuration and at least suggest 3. Okay. Okay. So see, like I have one data node, one name node, one secondary name node, and one balancer here. And these are the instance. So all those things are in good health. So let's get into the other part of web GUI. I mean, Hue. So this is where you will be working a lot. But as I said, like in production, you will be having the command line screen. But here it's very user friendly. You can select whatever, which tool you want to use. Okay. So here the username is Cloudera. So we have dvax command where you will be running queries of Hive here. So we will cover that in syllabus. And we have Impala tool and pig editor. Yes, as I said, like pig and Hive is most important here. So we'll be running that here also. And basically this is a file browser where you can see the directories that you make in command prompt. Also, you can see the Metastore manager here. Like I have added some POCs here and sample data sets. And Scoop. Sorry guys, I get used to get a lot of invites. And Scoop job, basically I have not implemented any yet. So let's get into job browser. So basically it's when you run a job here and you'll get in different colors, and this is basically a very colorful browser basically. Okay, so let's go to job designer. You can create any jobs like MapReduce jobs or Hive jobs. Okay. This is Uzi editor, of course. And Solr search. Not doing this yet. We have a huge shell as well. And this is HBase browser. Instead of going with command line traditional thing, you can create itself. And this is one of the projects that I've done. And so how many like you can find that. Okay, this is something warning here. Okay, so that's the end of the browser section. Let's run some Hadoop commands, guys. So I just clicked it from, let me show it, in the top window, I mean like top tab, I'll just simply click on it. So see, see if you want to have any help in the Hadoop system, so using help command the specific command of a specific command list with the usage information along with the pattern to use the commands. Okay, so what we will do is like Hadoop FS hyphen help ls. Okay, so this will list on all the things, all kind of helps. Okay, so next will be like we'll use you'll see the usage of HDFS shell command. Okay, like Hadoop fs hyphen usage ls. Okay, so basically this is usage commands which will give you the be used with a particular HDFS commands. Okay, so you can see that, right? What's next? Next, we can go for like okay. Let's use some syntax of Hadoop commands. Okay, so the command will be like fs hyphen ls. Okay, so this command is command will list all the available files and subdirectories under the default directories. Okay, for instance, in this example, like the default directory for Cloudera VM is user Cloudera, right? You can see that, right? And one more thing you must note that see there are some numbers here, 3 and 3 and 3 and 3. So basically, this is the replicated numbers. So this file, that is data underscore 10.txt, has been replicated 3 times. Okay, so this is how you can find how many times the files has been replicated. Okay, so let's go to the next command. Let's say Hadoop fs hyphen ls space /. Okay, so basically it returns all the available files and subdirectories present under the root directory. Okay, see, so we have HBase, Solr, temp, and users. So these are things. Okay, let's move to the next command. Hadoop fs hyphen what so ls hyphen r / user / so basically, like it returns all the available files and recursively lists all the subdirectories under the user of Cloudera. Okay, so I'm like we don't have much on this. We'll see that later. So next command will be like creating a directory. Okay, so it's a simple command we used in Unix as well. So mkdir. Okay, so it is used to create a new directory in HDFS at any given locations. Okay, so example like Hadoop fs hyphen mkdir / user / Cloudera / Okay, so I mean, like you can create this way, like Hadoop fs hyphen mkdir space. Okay, it says like it's already having. Let me see, like create something like Bangalore. Great. So we have okay. So you can find that it is not replicated here because I have not mentioned the replication. See the timestamp. Okay, so let's moving on. See, this basically cloud and other basically provide the directory which reads and read-write permissions. Okay, so to all users, but other directories are available as readers only, right? So create to create a folder in the root directory, user should always require a super user permissions. Okay, like I can tell you sudo -u HDFS Hadoop FS -mk // Okay, so the file is created. Okay, in sudo users. So let's copy from file from local. For example, we will use some sample text file which is available in the home location. Example like let's see. Okay, we have sample one. Okay, we'll use this. Okay, so what I'm doing is like Hadoop FS -copy caps F from caps L local sample one.csv to user cloud era. Let's say one. I know that. Let's say like practice one. Oh man. Okay. So basically, like, see, I have not created it in the local file, but basically this copy uploads is always available in home load locations. Okay, that is local, and the Cloudera also having the HDFS path as well. Okay, so I'll show that tomorrow because I was configuring few things and I just wanted to clear few of the things and it's taking much time. So I'll also add the command lines how to put and move from local and we'll also use other commands like du, df, expunge, cat, everything. Okay, so we'll see that in the next session. So I just winding up for now. And thank you so much, guys. And let's see more practicals from tomorrow onwards. Okay, so I'm sharing the document I have for command lines for your usage, and please go over on the drive itself. I mean, like I'm posting through Google Classroom. Okay, so that's it, guys. Thank you so much. Good night.